All right, so I think this is recording. Let's take a look at these three problems. They're exponential equations, and we want to solve each equation for x. And we're going to use properties of exponents and the fact that exponential functions are one-to-one functions in order to solve these. So on the number 10, we can try to rewrite each of these to have the same base. So the question is that I have, and I don't see my calculator handy, is that I want to determine how to rewrite 128. Do I want to write 128 as 2 raised to some power or as 4 raised to some power? And sometimes you can do both. So I think that 2 raised to the 7th power is 128. So yes. So on the left-hand side, if I rewrite 16 as 2 to the 4th power, and I rewrite 128 as 2 to the 7th power, then I can work towards getting a common base of 2. On the left-hand side, I have a power raised to a power, so I multiply the exponents. So I have 2 raised to the 4x squared minus 12x is equal to 2 to the 7th. Now, it's not because the 2's cancel, but exponential functions are one-to-one functions. So if the numbers are the same and the bases are the same, then the exponents have to be the same. And so this is a quadratic equation, and you're pretty familiar of all the type of equations that you've studied in high school. You've probably looked at quadratic equations the most. You know that you can always solve this through the quadratic formula or through completing the square. And oftentimes you can solve it by factoring. Let's see if by chance that we can factor this. Now, factoring is usually a little more difficult when the leading coefficient is not 1, and especially if the leading coefficient is not a prime number. With the number 4, we don't have a lot of factors to go through, but 1 times 4 is 4, and 2 times 2 is 4. So the composite numbers that have a lot of factors, this trial and error method involved with the X method can sometimes be a long process, but it's a very organized process, and that's the advantage. So if we multiply the first term times the last term, we have negative 28x. So we're looking for two values that multiply together to give us the top number, but add to give us the bottom. Well, I believe that if you double negative 14, then you'll get negative 28. But if we add negative 14x and 2x, we'll get negative 12x. And now, once you have, that's trial and error. So, sometimes you don't see that immediately. Sometimes you have to come off to the side and do a little bit of scratch work to find these two numbers to complete your x. But once you find them, we then suggest that you come over and put the results in the form of a table so to help you factor this. So along one diagonal goes the first term and the last term from the original equation, and along the other diagonal goes the two numbers that you found from your x. And it doesn't matter along the diagonal, those are interchangeable. And now we look both horizontally and vertically to factor each row and each column. So here I can see that a common factor is negative 7, and here I can see that these are prime with respect to each other, but they don't have a common factor other than the number 1. Horizontally here I can see these are both even numbers, they both have a variable, and here I can see they're both even numbers and they both have a variable. And now I can check real quick to see if I've made any silly errors. 2x times 2x is 4x squared, 1 times 2x is 2x, negative 7 times 2x is negative 14x, and 1 times negative 7 is negative 7. So I haven't made any type of silly error. So I can come back from this scratch work and come over here to my equation and say that this guy factors to 2x plus 1 times 2x minus 7. And if that's equal to 0, by the zero coefficient theorem, that means that either 2x plus 1, that this first factor is 0, or the second factor is 0. And so each of these are two-step equations. Over here, if we subtract 1 and divide by 2, we'll have our solution. And over here, if we add 7 and divide by 2, we'll have our solution. So this exponential equation has two solutions, -1/2 and +7/2. All right. Let's take a look at this next one. Try to give myself a little bit of room here. All right. So I can see on the left-hand side there's two terms, and I want to get the first term by itself because the second term doesn't have a variable. So I'm going to add 25 to each side. So on the left-hand side, I have this first term, 5 raised to this x squared minus 2x. And 10 squared I know is 100. And if I add 25 to that, I'll have 125. So now I can rewrite the right-hand side. I can rewrite 125 as 5 to the third power. So I have a base of 5 on the right-hand side. I have a base of 5, well, on the left-hand side, and a base of 5 on the right-hand side. If the numbers are the same and the bases are the same, the exponents must be the same. So I have a quadratic equation. So don't forget to get it in standard form, to have it set equal to 0. And from here, you can try to make a decision of whether you want to use the quadratic formula or complete the square or maybe factor it. With a leading coefficient of 1, those are generally easier to factor if you can do it. Two numbers that multiply together to give us -3, but add to give us a -2 are, I need +1 and -3, because 1 and -3 multiply to -3, but 1 and -3 add to -2. So then that gives me two solutions that are easy to see, -1 and +3 from that zero coefficient theorem. All right, so let's take a look at this last one. With 16 and 32, we have to try to make a decision of what base do we want to rewrite these. Well, sometimes with 16, you can use a base of 4, or you can use a base of 2. But when I look at 32, I can't write that with the base of 4, but I can write it with the base of 2. So that's what I'm going to try to rewrite these with the base of 2. So this 16 can be rewritten as 2 to the 4th power. And this 32 can be rewritten as 2 to the 5th power. So now, using my properties of exponents, if I have a power raised to a power, I multiply the exponent. So I've got 4x squared minus 4. And on the right-hand side, 5x minus 5. Minus 5, I wrote 1. Since these numbers are the same and the bases are the same, the exponents must be the same because it's a one-to-one function. This is a quadratic equation, so let's get this in standard form. 4x squared minus 5x plus 1. And let's try to use the x method to determine. If we cannot factor it, we know we can always use the quadratic formula. So over here on the right, if I make an x where the bottom of the x, now a lot of people just write the x over the middle term, and I do that sometimes, but I most of the time don't like to do that because if I draw an X through that negative sign, I often sometimes accidentally will then change that to a positive sign. If I'm sloppy in how I'm writing my X over this equation here, then sometimes I'll make a silly error just because later on I can't read my own handwriting. So two numbers that multiply together to give us the negative 5x, but add together to, multiply, I got that backwards. When you multiply these, you're trying to get the top value. And when you add them, you're trying to get the bottom value. And that's easy to get back. Don't slow down and make sure that you don't make that mistake. I almost did that. Now, you would be able to catch it because later on it just wouldn't make sense. All right, so, excuse me. Along one diagonal, I put the first term and the last term from my equation. And along the other diagonal, I pick off the values that I found in my X. And it doesn't matter on these diagonals. These spots are interchangeable. The table is just going to help me to factor both horizontally and vertically. Whenever I have a positive 1 in the right-hand corner and these negative signs along the diagonal here, I know that I'm going to need negative values on the outside here. Negative 1 times a negative 1 is positive 1. But here, with the 4x squared and 4x, I can see that 4 divides each of those, and it has a variable, and 4x times negative 1 is negative 4x. Vertically here, the 4 and negative 1 only share a common factor of 1, but they both have an x. And 4x times 1x is 4x squared, and 1x times negative 1 is negative 1x. So everything looks good. So that means I can rewrite this equation. I can rewrite the left-hand side to be x minus 1 and times the quantity 4x minus 1, and that equals 0. So here we can easily see that x equals 1, and here, if you have to write it out, it's 2 steps. Add 1 and divide by 4. And here we have our 2 solutions for this number 12. So hey, I hope that helps. Ask any questions as needed. Let me know if I've made some type of silly arithmetic error, or especially check sign errors. Talk to you later. Bye.